Hello, students, and welcome. So, you've seen those coding, decoding questions in your exams, right? The ones with all those strange symbols that look easy but end up eating all your time? Well, today, let's solve this puzzle once and for all and uncover all its secrets. So, here's your challenge. The symbol at is 0, okay? But then $ at suddenly becomes 2. What's the logic here? Looks confusing, doesn't it? In competitive exams, every single second is precious, and it's questions like these that can really make or break your rank. So, let's break it down. The secret to this isn't hidden in some complicated formula. Nope, it's actually a very, very simple concept. So come on, let's crack this code together. Okay, here it is. This is the single most important rule you need to remember. At is just a 0 and $ is just a 1. That's it. The entire system is built on this one simple rule. This right here is the master key to the whole code.
And does 0 and 1 ring a bell? Of course it does. This is just the binary system. You know, the base 2 number system. It's the same language that all computers use. The examiner has just wrapped it up in fancy symbols to confuse you.
All right, so now that we know the secret, let's first learn how to convert any normal decimal number into these symbols. For this, we're going to use something called the division method. The process is really simple. You just keep dividing the number by 2 until the quotient becomes 0. At every step, you note down the remainder. In the end, you just read those remainders from the bottom to the top. That's your binary code. Let's look at an example. Take the number 19. We divide 19 by 2. The remainder is 1. Then we take the quotient, 9, and divide that. The remainder is 1. We keep doing this, and we get the remainders, 1, 0, 0, 1, 1. Now, reading them from the bottom up gives us 1, 0, 0, 1, 1. Just replace the 1s with $ and the 0s with @ sign, and there's our answer, $ at. But let's be real, who has that kind of time in an exam? The division method is great for understanding the concept, but for speed, we definitely need a shortcut. Okay, for this shortcut, you just need to remember the powers of 2. 1, 2, 4, 8, 16, 32, and so on. Now, let's say we need the code for 25. Just think, which of these powers add up to make 25? Well, it's 16 plus 8 plus 1. So you just put a 1, which is our $, in the place of 16, 8, and 1, and a 0, our at, in the places for 4 and 2. And the code is ready, $, at, $. Now let's look at the reverse process. What if you're given the code and you need to find the number? This is just as important. This method is even easier, trust me. You just write the powers of 2 below the code, starting from right to left, 1, 2, 4, 8, 16. Now wherever you see a $, or a 1, you just add up the power values above it. That's really all there is to it. For example, let's decode $. We'll write the powers underneath it from the right, 1, 2, 4, 8, 16. Now, which numbers are below a $? We have 16, 8, 4, and 1. Just add them up. 16 plus 8 plus 4 plus 1 equals 29. Simple, right? Decoded. Okay, so far, so good. But you know exams. There's always a chance for a twist. What happens if the code itself changes? Let's take it to the next level. So, in the first system, we had 2 symbols, at and $, which is why it was base 2. Now imagine a new symbol, hashtag, is introduced. So now we have 3 symbols in total. This means the system is now base 3, which we call a ternary system. And in this, the values will be 0, 1, and 2. And please don't get scared by this. The logic stays exactly the same. Before, we were dividing by 2, so now we'll just divide by 3. That's it. Look, let's convert the number 98. We divide 98 by 3. The remainder is 2. Then the quotient, 32, by 3. The remainder is again 2. We repeat the process, write down the remainders from bottom up, and then just replace 0 with at, 1 with $, and 2 with hashtag. See? Same logic, just a different base. So, let's take everything we've learned and pack it into a simple exam-winning strategy. This is your 3-step master plan for any code they can possibly throw at you. Step 1, identify the symbols. How many are there? If there are 2, it's base 2. If there are 3, it's base 3. Simple. Step 2, assign the values, always starting from 0. So 0, 1, 2, and so on. And finally, step 3, apply the division or the powers method using the correct base number. That's your master plan.
So now, whether the code is binary or ternary, I'm absolutely sure you can crack it.
The key is just to identify the base. अगर आपको ये वीडियो हेल्पफुल लगी हो तो लाइक, शेयर और सब्सक्राइब करना ना भूलें और कमेंट करके बताएं अगर आप किसी स्पेसिफिक टॉपिक